Okay, average, I did it again. I always start like, okay. Average rate of change and operations with functions. So slope and rate of change are essentially the same thing, sort of. I'll talk about the difference, okay? So slope is rise over run. So it's the change in y over the change in x. So if we look at this is just a linear function, right? The slope is rise over run. So it's how far we go up. So here it looks like I went up 3. Then I go to the right 4. So that's going to be 3 over 4. The slope is 3 over 4. And we typically use m for slope. I'm not sure why m, but we use m. So this one, so it's rise over run. So the rise here is, we actually would go down 8, right? So I went down 8, then I go to the right 4. So that's negative 8 over 4, which is going to be negative 2. So say you were given points, so negative 9, 3 and negative 5, 7. Well, we could just graph these points if we wanted to and then do it. Or we could just find the change in our y values over the change in our x values. So the y values here, that's going to be 3 and negative 7. So the change means we're going to subtract them. So 3 minus negative 7 over the change in our x values. So negative 9 minus negative 5. And notice how these ones both came first and these came second. Okay, that's very important. You could have flip-flopped them, but just make sure whatever one you put first, like on the top, is first on the bottom also. But then 3 minus negative 7 is 3 plus 7, and negative 9 minus negative 5 is the same as negative 9 plus 5. So that's 10 over negative 4, which is negative 5 halves. Okay, and I'm just going to show you here that if we flip-flop the order we do this in, you're just going to get the same thing. So negative 7 minus 3 over negative 5 minus negative 9, which is negative 7 minus 3, negative 5 plus 9, which is negative 10 over 4, which is negative 5 halves. Same thing, okay? Don't forget that. Okay, rate of change. So for linear functions, the slope is constant between two pairs of points. But if we're looking at different types of functions now, so for non-linear function, the slope changes between different pairs of points. This is why we call it the average rate of change, because it's not a constant slope anymore. We're given 2 points and we have to find the rate of change between those 2 points. Okay, the average rate of change of a function between 2 points is the slope of the line that passes through those points. So we're really looking at like a linear line here, and we're finding the slope of that line. This is called a secant line. Okay, that is called a secant line. So say we're given this function that is graphed below, and we want to find the average rate of change on each interval. So from negative 2 to 1. So if I go back to negative 2, remember, slope is rise over run. So if I go back to negative 2, it looks like that point right there is negative 2, 1. Okay, and then let's go to 1, also right there. And it looks like that point right there is 1, negative 8. So we're trying to find the slope of the line that passes through those 2 points right there. Okay, and we could just like look at this and see like, oh, okay, well I go over 1, 2, 3, and I go down 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's rise over run. So that's going to be down 9 over 3. So I'm guessing this is negative 3. Let's see if I'm right. So we could do 1 minus negative 8 if we're going to do this algebraically, and negative 2 minus 1. Which is 1 plus 8 over negative 2 minus 1, which is 9 over negative 3, which is negative 3. Okay, so we're just finding the slope of the line that passes through those 2 points. Okay, now let's look at this. We're not given a graph here. So we need to figure out, we're given negative x squared plus 6x minus 14 on the interval from negative 1 to 2. So I just need to figure out what are the y values at these points. So at negative 1, if I plug that in, I'm just going to put that whole thing in the calculator, I get negative 21. So that first point will be negative 1, negative 21. If I plug in 2, I get negative 6. So then 2, negative 6. Then again, it's the change in y over the change in x. So negative 21 minus negative 6 over negative 1 minus 2, which is negative 21 plus 6 over negative 3. So negative 15 over negative 3, which is 5. Cool. Cool? This one, so again, same thing. We need to figure out what the point is there. So if I plug in 2, that's 2 minus 4 over 2, which is negative 2 over 2, which is negative 1. So 2, negative 1. I plug in 8. 8 minus 4 over 8, that's 4/8, which is 1/2. And then, to find the slope of the secant line, it's going to be negative 1 minus 1/2 over 2 minus 8, which that is going to be negative 3/2 over negative 6, which is the same as negative 3/2 divided by 6, which we could write it as dividing by 6 if this helps us. And remember, when you divide by something, that's the same as multiplying by the reciprocal. So I'm just going to multiply by 1/6, which I get 3/12, which is 1/4. Okay, so that means the slope of the line between those 2 points is 1/4. Okay, let's get into some operations with functions now. So that was all of the rate of change stuff. So we're kind of switching directions here. This is going to be operations with functions. So we're given these two functions. We're given f of x equals x squared plus x, and g of x equals 3x plus 1, or minus 1. And I want to know what f plus g of x is. Well, that's the same as saying f of x plus g of x. So that's going to be x squared plus x plus 3x minus 1, which ends up being x squared plus 4x minus 1. Pretty straightforward. Should be okay with that. So f minus g of x, well, that's the same as f of x minus g of x. So that's going to be x squared plus x minus 3x minus 1. Mama said, don't forget to distribute the negative. Remember, anytime there's a subtraction, you distribute that negative. So that's the same as negative 3x plus 1. Now we can combine, so that's x squared minus 2x plus 1. So f times g of x, well, let's just guess, we're probably multiplying these. So f of x times g of x. So it's x squared plus x times 3x minus 1. Which if you multiply that out, you end up getting 3x squared plus 2x squared, or 3x cubed plus 2x squared minus x. This last one, f over g of x, well, that's going to be f of x over g of x, which is going to be x squared plus x over 3x minus 1, which there's really nothing we can do there. We're just going to leave it. Okay? Okay, so this is the more complicated stuff. This is called composition of functions, or function composition. This is applying one function in the result of another. So the result of f is sent through g, and that is written as g of f of x, which really means g, and then you could put the of f of x into there. Okay, so whatever this is goes inside of the g. Okay, so let's go through some examples of this. So here, if I'm given f of g of 3, well, I always rewrite this. So that's the same as f of g of 3. This notation makes more sense to my brain than this notation does. This is telling me that I'm going to plug g of 3 into f of x. This one, it's telling us the same thing. This one just makes more sense to me. But, so g of 3. So I need to find out what g of 3 is. Well, g of 3 is 3 plus 1, which is 4. So now I'm finding f of 4. And I'm going to plug 4 into the f of x function. So that's going to be negative 2 times 4, absolute value of that, which is negative 8, which is 8. Cool? So now let's find g of f of negative 5. So I'm going to just rewrite it. So g parentheses f negative 5 parentheses. So I need to first find out what f of negative 5 is. So I'm going to plug that in. So that's going to be negative 2 times negative 5, which is 10. And so I'm going to be finding g of 10, and then I just plug 10 in for g, which is 10 plus 1, which is 11. Okay, this one right here, so f of g of 9. So that means I'm going to find g of 9 first, and then plug it into f. So g of 9 is 9 minus 4, which is the square root of 5. I'm going to leave it as the square root of 5. Okay? So then I'm going to plug that into f, which is going to be the square root of 5 squared plus 5 times the square root of 5, which the square root of 5 squared is 5. 5 times the square root of 5 is we're just going to leave it as 5 square roots of 5. If I do this one, g of f of 7, well, I'm going to find out what f of 7 is first and then plug it into g. So f of 7, that's 7 squared plus 5 times 7, which is 84, because that's 49 plus 35, which is 84. So this is going to be g of 84. Plug that in. So 84 minus 4 is the square root of 80, which we can break down to be 4 square roots of 5. Cool? Okay, this one. So we're not given a number now. We're just finding f of g of x. So I'm going to take g of x and plug it into f. So g of x is x squared minus 4. So that's what I'm going to plug into f. So wherever there's an x there, I'm going to plug a x squared minus 4. So I have x squared minus 4 plus 7, which is the same as x squared plus 3. This one, g of f of x. So I'm going to plug in f of x into g. So that's going to be g of x plus 7. So if I plug in x plus 7, it's going to be x plus 7 squared minus 4. Which x plus 7 squared is x squared plus 14x plus 49 minus 4, which is x squared plus 14x plus 45. Cool? Okay, so f of x equals 3 minus x, g of x equals x plus 1, and we're asked to find f of g of x. So we're plugging g of x into f of x. So that's going to be x over x plus 1, so that's 3 minus x over x plus 1. This is kind of a future topic, but think if we had like 2/3 and we were adding a 1/4, or I'll do it a little bit differently. So say I was adding 2 plus 1/3. Well, I could change this 2 to have a common denominator here, right? I can multiply by 3 over 3. So this would be the same as 6 over 3 plus 1 over 3, which ends up equals 7 over 3. Right? So we're going to do that here. I'm going to multiply that first one by x plus 1. So I get 3x plus 3 over x plus 1 minus x over x plus 1, which ends up equaling 2x plus 3 over x plus 1. Cool? So if we have g of f of x, that's going to be plugging f of x into g. So that's 3 minus x going into f of x, or g of x. So that's 3 minus x over 3 minus x plus 1, which is 3 minus x over 4 minus x. And we're just going to leave it. Oh, it looks like it's done. It's not goodbye, but it's I'll see you later. Okay. That was corny. Goodbye.